400 miles southeast of Sydney, in the middle of nowhere, burns a spark of invention. In this lonely corner of the outback, creating clean energy is one man's dream.
That dream became a passion. And from a passion, it's become an almost unhealthy obsession.
Roger Davey is obsessed with an overlooked source of power, the sun. Here they see so much of it, they've given the area a name. Roger Davey will build a solar plant on the scale never seen before.
It is spectacular. The top of the tower would be right at about our eyesight as we're situated right now, at about 65 metres across, or what's that, about 190 feet in diameter.
He calls it the Solar Power Tower. It will be the world's biggest solar power plant and one of the tallest objects ever built. It will rise 400 feet taller than Taipei 101, the world's tallest building. Around the base, a sheet of glass 6 times the size of New York's Central Park.
It's a vast area even from up here, isn't it? And the tower in the centre, 600 metres tall. It really is a sight.
Unlike traditional solar plants, Rogers Tower is powered by the same principle that keeps this balloon aloft: rising hot air. The sun's rays beat down on the glass and heat the air trapped underneath.
Hot air rises, so the air runs towards the centre where the tower is situated. And just like a cold day when you light a fire, the smoke goes whoosh up the chimney, runs through turbines, the turbines spin through the generators, generating electricity, which I think is almost the holy grail of renewable energy.
The energy feeds into a grid station just 5 miles away. The tower will produce enough energy to power 100,000 homes without burning a single lump of coal. The effect on air quality? Like taking 90,000 cars off the road.
It is clean, it is green, it is the way of the future. People have started to worry about the environment. They've started to worry about clean air. They've started to worry about emissions of fossil fuels. And if you can reduce those totally, or at least in part, you're doing something for future generations. You will slow down climate change or slow down global warming.
In Australia, they're tapping the sun. In Britain, they're creating the sun. Here on Earth. Our sun is almost 1.5 million times bigger than Earth. A giant ball of pure energy. Just 1 second of the sun's energy would power Earth for 1 million years. What fuels the sun is a nuclear reaction called fusion. Capture just a fraction of this power, and we solve our energy needs forever. We don't need to travel 93 million miles to get it. It's already here. These scientists are about to recreate the power of the sun. They'll use one of the most complex machines ever built. Next to NASA's space station, this is the largest science project in the world. It took thousands of scientists 29 years to build. Its aim? To control one of the most powerful forces in the universe.
Fusion is important because it's something that's going to give us a really, really long-term sustainable energy source.
What Hugh and his colleagues achieve here could fulfill what's now just a dream. An unlimited supply of cheap, clean energy. Inside the torus reactor, atoms aren't split apart, they're fused together. A cleaner process that uses no radioactive plutonium or uranium. The fuel for fusion is hydrogen. Hydrogen atoms are heated to 150 million degrees, 10 times hotter than the sun's core. At this extreme temperature, the atoms turn into plasma. The plasma atoms collide and fuse. The reaction releases a neutron of pure energy. It's 1 million times more efficient than today's nuclear power, and 1 trillion times more efficient than fossil fuel. Clean energy, but a risky process. More than 160 safety checks take place before the countdown. If one is missed, the forces inside the machine could escape.
Everything we do, we need to be totally sure we've got everything right. We can't afford any mistakes, and it can be a little bit tense at times.
To protect the scientists, the machine is encased inside 6 feet of concrete and steel. Even so, the scientists work from the safety of a separate building.
Trigger the pulse, please.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
A camera records the reaction. The glowing light is plasma heated to 150 million degrees. The reaction produces energy just like our sun. In mere seconds, fusion here on Earth.
We did good.
That was excellent. That worked exactly as we wanted it.
It's perfect.
I'm happy. I think the scientific coordinators are very happy. You can see lots of smiles, in fact, so, which is good.
Nowhere in the world have scientists come closer to creating the ultimate energy source. And the fuel for fusion is virtually unlimited.
1 bathful of water would provide enough energy through fusion to supply one person with all their energy needs. So their transport, their heating, their food, their industrial needs for 30 years.
Because fusion uses water, there are no security risks, no meltdowns, no downside at all to living next door to a fusion reactor. But don't look for one soon. Scientists estimate it will take 50 years before we have a working fusion power plant.
This is a very long-term strategy. This isn't something that's suddenly going to produce a result tomorrow and solve all our problems. So we will get there. I don't think we have any choice.
While we wait for fusion, the world will need every other source of clean energy. Because if we don't clean up our act, Mother Nature has a nasty surprise. How long do we have before we run out of fuel? Cheap oil and gas may last decades. Coal could last centuries. But a more pressing deadline looms. The threat? Global warming, fueled by burning coal and oil. The consequences? Storms. Floods. Drought. UN scientists say we have just 10 years to mend our ways.
We can't afford to sit back and just wait and see what happens. If we want to deal with the future challenges of climate change, we have to act today.